There's that graph. And then the other one is you basically turn it this way. Now some of you might have thought, okay, well you flip this over, you flip it. No, the best thing for you to do is to draw a picture of the negative if you don't know it. Another one that I would draw a picture of if I was you is y is equal to the square root of x. So x to the 0.5 and then negative x to the 0.5. And yes, x to the negative 0.5 is the square root of x. Even though I have to tell college students that, I don't know why. They should have learned that in algebra. Algebra 1 and 2, they should have told you that. And anytime you raise something to the 1/2 power, that's the same thing as the square root. But I find people who don't know that, and there's nothing wrong with it. Just, okay, you got to put negative around the.
No,
okay.
you left the parentheses.
This, yeah, you got to put it. Hold on. Yeah. Plus, you might want to put. Where's the delete? There it is. Okay, you might want to put parentheses around this guy too. Because the calculator, believe it or not, some people that carry it to the bathroom and name them, they do not know everything, okay? You don't want to grow up and be those people that can't make change, okay? Always remember a sideways parabola, okay? A sideways parabola makes up x squared, the square root of x and the negative square root of x, okay? Just something that you might want to remember. Because those two are the aggravating ones as far as the negatives go. Y'all come up with some weird graphs of the negatives of those two, all right? So let's go back to the problem at hand, and that's this guy. Now we know that parent graph says okay, there's the parent graph. I'm going to copy it before I do everything else in case I need it really. All right. Y'all get the point. Okay? That's that one. And this negative, we just said that basically it turns it what? Turns it this way, doesn't it? So it's not going to let me turn it. I don't think it'll. Kind of like that right there. Okay, well that's going to screw up now. I'm not going to be able to. We'll just do this. We'll just dang on turn it this way. There we go. Dang on more than one way to skin a what? You skin a cat? Good. If you don't know what I'm talking about, it's your parents' fault. And bushes. So now we've just turned it around. So that's done. We just did that. And now this 4 tells us we're going to move it which way?
To the right.
4 to the right. And of course it's not going to let us. Nope. Look at. So this is what I'll do. I'll just draw with a red line or a blue line. 1, 2, 3, 4. There's our vertical asymptote. Or that's our vertical asymptote, 4. And then what does this tell us? 7 up. 1, 1, 2, 3, 4, 5, 6, 7. So now we're going to take this guy and put him where? Oh, forget it. I'll just draw it. He'll go right here. Like that. Y'all ought to appreciate me. I'm doing the best I can up here. And the other one is going this way. And that's what it looks like. So, what's your domain? All numbers except for 4. So, all numbers except for 4. So, let me just write it. That's your domain. Range, negative infinity to what? 7, and then from 7 to infinity. Be careful, this may be a union or an intersection. I don't really care about that, but all I care about is that you get these parentheses right and you get the numbers right.
How's it going to take it in my labs? Is it going to want you to do the union?
Yeah, it'll have a union.
The U thingy?
Mm-hmm. It's not an intersection, because intersection will be overlap. Here, there's no overlap. You start here, you go to here. Do you overlap with this guy?
No.
No. So it's not an intersection. So don't do the intersection. Anything with an intersection, it's not the answer. This is what they'll have. They'll have this with a U. And that's what you pick. And the increasing from negative infinity to 4, from 4 to what?
Positive infinity.
That's increasing, and this is, wait a minute, they're both increasing, aren't they?
Yeah.
Both increasing. So it'd be increasing from negative infinity to 4 and increasing from 4 to infinity. Now, I don't know if they cover vertical asymptotes, but we're going to talk about that a little bit. Somebody tell me if they cover vertical asymptotes in chapter 2. I believe they do. Like 2.6 or 2.5. I think they do. We'll just go ahead and go over them. Somebody look up how you spell them. Asymptotes. I don't know if it's totes or totes. I never have.
Well, I think that's the way they spell it.
I can't remember. Don't say nothing, because some of y'all can't spell necessary, and you've been in school for 12, 15 years.
Hey,
Huh?
you're a math major, not an English.
No, hey. Necessary, I can't even spell necessary. I want to put 2 C's and 2 S's. I don't know if that's right or not. All right, whatever it is, asymptotes with a P or totes, it's the same thing. All right, vertical asymptotes. Set, radical, or radicand, or what? Denominator equal to what? 0. And that's how you find the vertical asymptotes. Now, in some problems, you will be able to factor before you can set equal. I did spell it right. Okay, it's totes, like same old umbrella, totes, same old asymptote. Some people know like tote water, to carry. I wonder where tote comes from. You have to look up the origin of tote. I just wonder if some redneck from South Carolina came up with that word, or does it have some kind of origin to Latin origins? Tote. 2, sometimes you will have to factor, then set equal to 0. Example, x plus x squared plus 4x plus 4 over x plus 2 to the third power. All right, now, if you use the first rule, you just set the denominator equal to negative, or to, and you get negative 2. Set it equal to 0, you get negative 2. But you can't do that yet. The reason you can't do it yet is it's not in the simplest what? Form. So in order to set the radicand or denominator equal to 0, you have to have it in simplest what? I don't think that's right. Form. So that means I've got to factor the top and see if anything will what? Cancel. X plus 2 quantity squared over x plus 2 to the third power, and what happens? These two will cancel with these two and leave x plus 2 what? Now you can set equal to 0. Now of course it's still x minus 2, but it's not always going to be the same answer, because sometimes you're going to factor this, like this will be a trinomial and you're going to factor this, so you can't set it equal to 0 because you need to find out if anything cancels. When you see a graph and you see an open circle, on a graph, open curls, open circle, when you see an open circle on a graph like this, and you see an open circle right there like that, that means that there is some factoring. That means that there is some factoring going on with the problem. And then after you do that, after you see the circle, you see a vertical what? Asymptote, like right here. When you've got a circle, an open circle and a vertical asymptote, that means that the circle goes with the pre-factoring. Circle goes with the pre-factor. And then the vertical asymptote goes with the what? Simplest form. So you might want to write that down for later. Because some of you may be doing homework and you'll be doing a problem, and the problem starts off with x minus 2 in the denominator, or I don't know, we'll find an example. And you go, okay, vertical asymptote is 2. And then you get the answer, and the answer has a circle at negative 2, and then it has a vertical asymptote at 5, or whatever the case may be. And that's because that the open circle goes with the non-factored, and the vertical asymptote goes with the simplest form. And this may not be equal to this. And we'll get to examples of that. So just make sure you understand that when you find the vertical asymptote, you're going to set the radicand or the denominator equal to 0. But make sure that when you're dealing with the denominator, that it's in the simplest form before you set equal. I'm trying to think of an example. But horizontal asymptotes. Now this is in your book somewhere. There is and if somebody has their book handy, look for that page. I don't see anybody with a book, but oh well, a bunch of losers.
What page?
I don't know. It's where it says horizontal asymptotes. Look in 2.5, 2.4, somewhere in there. Look for horizontal asymptotes. And you've got 3 conditions. And the 3 conditions are based on the degree of the denominator and the degree of the numerator. Let me find it. Let's see if I can find it. It may not. It might be. before, but I don't see it, so I need a table of contents, dang old search, dang old horizontal. Ah, spelled it wrong. I'm forgetting something, it should be a Y in there, dang old Y. Okay, it's chapter 4, probably. That's not the page I'm looking for, but there's a page, so it's in chapter 4, we don't have to worry about it. Now, I would like to find it so you had it, so I'm going to find it right quick, so just bear with me. It's probably in that section. Give me a second. Okay, well, I don't know where it is. Yeah, maybe in chapter 3. I don't know. I don't think it's in chapter 3. Huh? I didn't hear you.
What were you looking for?
Horizontal asymptotes.
It's in like 4.2.
Okay, 4.2. There it is, page 279. Right there. So you need to make a note on page 279, and I'm just going over it. We're going to go over it again. Right here. 279. So make a note of it. And it says right here, if the numerator has a lesser degree than the denominator. So I'm going to go over here. If the numerator has a lesser degree, numerator has a lesser degree, and I'm going to go denominator, degree minus 1. Alright? If the numerator has a lesser degree than the denominator, I'll give you an example. X squared over, or X over X squared. Is that a lesser degree? Yes. The degree of the numerator is the first degree. The degree of the denominator is what? Second degree, Hubert. Thank you, class. Then you go with the coefficients. In this case, the coefficient is 1, or let's say 0. I'm sorry, 0. I've got it mixed up. Should be 0. Where's the... Yeah. It is 0 for the denominator, but not the numerator. Yeah. Equal to 0. Line is the x is equal to a is a vertical asymptote. Alright, so if find any vertical asymptote by setting the denominator, oh, I did that one. I'm talking about here. Here we go. If the numerator has lesser degree than the denominator, then the horizontal asymptote is 0. So on that, coefficient is 0. I've got that mixed up with the second one. Much easier to do this when you got an example. So if you was to draw this, you know the vertical asymptote, the horizontal asymptote would be the actual what? Well, what? When the horizontal asymptote is 0, that's the x-axis. Okay. Now, what about when the degree of the numerator is the same as the degree of the denominator? When the degree of the numerator and the degree of the denominator is the same, meaning d and d, in other words, 2x squared over x squared, then you go with the coefficients. So the horizontal asymptote here is equal to 2. So that one would be 1, 2. So your horizontal asymptote would be x is equal to 2, or, yeah, y is equal to 2. And then the last one is the one y'all really love. And we won't do it, but the one y'all really love is if the degree of the numerator is higher than the degree of the denominator. And what do you do then? Dang old y'all's favorite subject. Long what? Division. You divide. And we'll do that in chapter 4. All right, let's get back to what we were doing. So let's say you understand all of your family of graphs. You should be able to do those now. Let's get back to the quadratic. Let's move up. We've done a 5, we've done a 3, and we've done the Mickey Mouse x squared plus 4x plus 4, the easy ones. We did those, 1 and 2. Let's move up to 3. What would 3 be? F of x. Well, we can do the 0 later. What's wrong with this one? That's not rhetorical, I'm asking y'all.
It's negative?
It's got a negative in front of the what? In front of the x squared. You can't do complete the square with a negative right there. So what do? Erase it? Yeah, erase it. Move on to the next problem. Mr. McClure, I don't understand why you erased the negative. Okay. Did I do that? Yes. All right. So remember, you can't. Ooh, that looks awful. You can't do completing the square with negative a. Okay? Can't do it. And we're going to draw a little arrow or an arrow, depending on where you're from. Right there. And we're going to take a red marker and we're going to draw a negative right there. So you put cannot be done and you go to the next problem, right? Nothing is that easy. Okay? So what do? Well, first of all, you move C like you always do. So take your handy dandy black marker. Set equal to 0, negative x squared plus 2x minus 7 is equal to 0. I'm setting y is equal to 0 so I can get my x-intercepts. Move C, negative x squared plus 2x plus blank is equal to 7 plus blank. I'm going to paint that one red again, because we're stuck on this thing right there. That negative is causing a problem. So we've got to factor it out. Now, in order to factor it out, we've got to remember a rule. Whatever you factor out, you have to multiply right side blank by that number. Okay? Now write that rule, and I want you to highlight it. I want you to put a cloud around it. I want you to put stars around it. I don't care. I want you to paint it red, because what you're going to do is you're going to forget to do that on the test. So what do I need to factor out? What's in front of this x squared? Is it just a negative by itself?
-1.
It's a -1. So you got to factor out a -1, and you got to multiply -1 by that right-hand side over there. Now this is where I need to tell you, just trust me, all right? Because I can show you why, but I would have to go back to the completing the square completely on the left-hand side of the equal sign, which I don't show y'all because it's confusing. So if you want me to confuse you, then really confuse you, then we'll do that, but I don't want to do that. So I'm going to factor out the -1, I'm going to do it and read it. So -1, and then parentheses. That'll get, and I'm just showing these parentheses. You don't have to write parentheses around these two, but I'm just showing you. So I'm going to make this one and this one, I'm going to make them dotted, meaning that you don't have to put them around these two numbers right here. And what will that make this? What's -x squared divided by -1?
X squared.
X squared.
And there's our nice positive x squared that we need. And what's 2x divided by -1?
Negative.
And then plus blank is equal to 7 plus, hold on a minute. Plus -1 times blank. Okay, whatever you factor out here, you've got to multiply by this right-hand side blank. And that's what y'all going to forget. Y'all going to be coming up here, you're going to be saying, Hubert, I did this problem 5 times. And you send it to me, and I go over it, and I will do it, and I'll say multiply this -1 times blank, and you'll go, dang it! Because you forgot to do it. Yes, sir.
So you don't do the whole right side, just that whole little one?
Just that one, yeah. Don't ask why. I know you want to. But it all goes back. And if you look in your book in chapter 2 or 3, chapter 3, we're in chapter 3 right now. If you go back in there, you'll see that they teach you how to do all of this on the left-hand side. And when you do it on the left-hand side, you multiply this negative times whatever's here and here. And that's why you do it. It's because it comes from another version of completing the square. And you can look in your book. I'll show you where it is when we get to it, but I'm just going to show you and keep going. I'm not going to do it. All right, so now we can do what here?
Divided by 2 and squared.
Complete the square. We can complete the square now. I'm going to take this over to the next page because I don't want to do it right here because it's too. Now, another thing that y'all are going to forget to do. Y'all going to factor that -1 out, or you'll try to do complete the square before you factor out the -1. All right. Go back to this page. I want you everybody to make a note on your notes. This today is the 9th of February 2015 datum, because when we get to this and y'all give me a homework problem and you say, I went over this problem 5 or 6 times and I don't understand what I'm doing wrong, I'm going to go through the problem and Miss Anderson, she's going to say, well, I thought we were supposed to complete the square first. And I'm going to say, go to your notes on whatever today is, and y'all going to go back to those notes, and it says right here, before I can complete the square, right here, you can't complete the square with a negative out front. So you tried to do that. I'm foreseeing this because that's what's going to happen. All right, so let's take our handy dandy whatever. Next page. Sorry. All right, I'm going to rewrite this, and I'm going to rewrite it in black now. -1 x squared minus 2x plus blank is equal to -7 plus -1 times blank. Now you're ready to complete the square with this in the parentheses. What's half of 2?
1.
2 divided by 2 is 1. 1 squared is 1. So 1 goes here and there. And that gives us shortcut number 2, which it either gives number 1 or number 2 based on what that is right there. And that's going to give us -1 times x minus 1 quantity squared is equal to, what's -7 minus 1?
-8.
Now you're ready to finish it, so finish it. What's our vertex? 1 and 8.